system. In education system, the biggest problem is one human being coming and telling another human being, how many times I should tell you? Still you have not understood that. That's the worst thing in an education system.
So we have done with Poisson ratio. Now we'll go for shear stress. This is very important to understand. My focus is you should practically understand so that you can really imagine that what actually is stress and what actually is shear stress, what actually is Poisson ratio. So I'll make you understand by an example. Let me say I will take one sheet of some thickness T. Okay, I'll take one more sheet of some thickness same T. Now I want to join these two bodies. Okay, if I have to join these two bodies, what I'll do is I will make a hole. I'll make a hole, correct? I'll make a hole, and what I'll do is I'll put rivet joints. Say I have made this two holes. After making these two holes, what I'll do is I'll put a rivet. Say this is the rivet. Say this is two rivets. I have made a hole on both the seats. I have made a rivet. Would have a head like this, correct? Which you can easily find on the trusses in the railway bridges, correct? So by using this rivet, what I have done, I have joined these two bodies. Now what happened, though I have joined this, after some time, say this comes with the application of pull. There will be a pull or there may be a push, anything. Now because of this, what happens, since these two are joined with this rivet, what happens, there will be shift in the alignment. Means what happens here is same thickness bodies. Because of this push or pull, what happens to rivet is it shifts. It shifts. Here also, what happens? It shifts. Right? Now this shift, what you are seeing, this is nothing but this is because of shearing. So basically what is shear is, shear if it is induced in a body and whenever it is subjected to equal and opposite force, you can see this, there are two forces, two are equal but opposite in nature. So whenever there is a equal and opposite force which are acting tangentially, these both are acting tangentially across the resisting section, then it is called as shear stress. That is, in simple, what I am going to do is I'll make one more diagram to make you understand better, because I want my student to understand practically what actually stress means. When someone says what is stress, you should know. When someone says what is shear stress, you should equally know the difference. Stress is nothing but the resistance force whichever falling on a particular area or a particular point of area of application, that is stress. But shear stress is a stress which is because of two equal and opposite, because of the stress that is created because of two equal and opposite forces which acts tangentially, right? Say for example, this is a load and by hand you are pushing with a force P. Now what happens when you give a force with P? Say here the member is weak. At this section the member is weak, XX section. So what happens when you push this towards the right, there will be a resultant force, correct? And what is that resultant force? R. So generally how can I show this? So here when you're pushing P, this is going along this direction, but there is a resultant direction in the opposite direction, right? So here shear stress, which I can denote it by this, that is called as tau. So this tau I can say is nothing but R by A, that is resistance shear, that is resistance shear, that is shear stress. I can write it as shear resistance by shear area. Which area? This area. Means this is the front view. Top view, how it will be? This will be something like this. So on this area, the R which is acting, this R which is nothing but the tangential opposite force. So this tangential opposite force is nothing but shear, and that shear, that force of shear is called as shear resistance force or shear resistance. So tau, that is shear stress, is nothing but shear resistance by shear area, that is force by area. Am I clear? I hope I am clear to all. Because in simple of otherwise how you can understand is, in simple you can say shear is nothing but tear. Say for example you take a paper. If you take a paper, say this is a A4 sheet paper or any paper, correct? Now if you have to tear this paper, how you can tear? If both the hands, if you put this way, it will never tear. But one hand you bring your side, you take a paper, small piece of paper and tear it. What you will see is one side you are holding or giving a force toward yourself and the other hand you are putting away. And this is because, what is this? This is equal force but opposite in nature, and because of this equal and opposite in nature, there will be tearing in the paper. So similarly, whenever there is a tearing in a material, in a solid object, we call that is nothing but that is shear. Instead of calling tear, we call it as shear, and that shear is nothing but opposite force, that is a resistance force on that particular area. I hope this is clear to everyone. Am I clear to all? Please put your answer if I am clear.
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way learning. Download our revolutionary app for free, AMC.